Dear students, today we are going to discuss industrial drives and application, module 4. The title of the module is Induction Motor Drives, continuation of your third module. In this, we are going to discuss voltage source inverter driven induction motor. Here you see your the voltage source inverter driven induction motor. So we are going to use six transistors. Okay, first you should know what is meant by voltage source inverter. Okay, so here the line A, B, C. Okay, these are the three lines. This A, B, C, this should be act as a voltage source in order to control the induction motor, so that it is said to be voltage source inverter. Okay, the line A, B, C, all this will be act as a source to control the induction motor. So it is called as a voltage source inverter. So that is the definition, voltage source inverter definition. And here in this topic, we are going to discuss what is the necessary we are using this voltage source inverter, and how it is going to control the induction motor, how it is going to operate the induction motor, and how it is going to control the induction motor, that we are going to discuss. Okay, so entire thing we are going to discuss that thing. And here the voltage source inverter driven induction motor, here we are going to use voltage to frequency control method. Here we are going to how to control the induction motor means by using V by F method. Okay, by using V by F method. And here there are two types. Actually, there are two types we are going to control the induction motor. One is square wave switching method or PWM switching method. Two different methods we can control the induction motor by using under the voltage source inverter. Two ways are there. One is square wave switching, the other one is PWM technique. The square wave switching method is also called as a stepped wave inverter, or full step inverter switching method. Okay, and again this inverter is operated in two modes. Okay, generally the inverter is operated in two modes. One is 180-degree mode and another one is 120-degree mode. But here we are going to discuss 180-degree mode. Okay, here we are going to discuss 180-degree mode. We are not going to discuss 120-degree mode. Okay, the inverter will operate in two mode. One is 120, the other one is 180. So here we are going to prefer 180-degree mode. And here, and also I said it is operated in two ways. One is square wave method or stepped wave method. The other one is PWM method. And we should know the major difference between the square wave switching method and PWM switching method. In square wave switching method, actually disadvantages is there. What it means, using this square wave method, only it will control only frequency. Internally, it will control only frequency. It will not control voltage or current internally. That is through inverter, using this voltage source inverter, it will not control your voltage or current. It will control only frequency. By varying the time period, we can control the frequency. And if you see PWM technique, it will control both voltage as well as your frequency. In PWM technique, you can control the frequency by varying the time, and we can control the voltage by varying the modulation index. By varying the modulation index, we can control the voltage also. But in square wave technique, it is not possible. Okay, so that is the disadvantages. Okay, and one more thing here. Here this is the circuit for providing variable voltage. This is the fixed voltage. The fixed voltage will be first. It is suppose if my available supply is DC. If my available supply is DC, according to that I am going to design the circuit. for providing the input to the six step inverter. Here is a step inverter. I told na the square wave inverter or a stepped inverter. Here we are going to use stepped inverter. Here I am going to use six transistor. That's why it is called as a six step inverter. You can the number of steps that you can choose according to your application. And here I am going to use a six step inverter. So because of the six transistors, the operation of this circuit I am not going to explain because it is already you have studied. Only here my concentration is only how to control the induction motor. Okay, that only I am going to concentrate. Two ways I can control. One is using square wave method, other one is PWM method. This circuit is for a square wave method or stepped method. Now here the available source is fixed DC supply. Now this fixed DC supply will be given to the chopper. Okay, given to the chopper, and this chopper, what it will do, it will produce pulsating DC. Okay, this chopper is producing pulsating DC, and this output will be given to the filter. The filter function, you know that this will be acting as a DC link, and also it will remove the ripples. Okay, and then it will provide the variable DC. And this variable DC I told na, so this is the external circuit for the square wave switching method or pulsed, this stepped method. You need external circuit to control the voltage. So here I am going to use external circuit to control the voltage. Okay, so then it is given to the inverter. The inverter here frequency will be controlled by varying the time. So in order to control the induction motor, suppose if my available supply is AC, what I have to do, instead of this chopper I am going to use controlled rectifier. What you know that rectifier means, it will convert AC to DC. Here it is controlled rectifier means you will have controlled output. Okay, so if you use thyristor, so we can control the output. Okay, according to requirements we can control the output. If it is uncontrolled means we will use generally diode. So diode is uncontrolled rectifier. This is controlled rectifier. Now, and this will be given to the filter. The filter will remove ripples, and then the variable DC will be given to the stepped inverter, and then we are going to control the induction motor. Okay. Now, so what I said earlier, these are the things about your square wave inverter. The gating signals, line voltage, and for square waveforms will be shown. That I will show in the next diagram. And this is the PWM principle. What I told, that same thing. So these are the different gate pulses. Okay, these are the different gate pulses and the line voltage for your PWM technique. Okay, so this is about your this one. This is the different gate pulses for your 6 thyristors. We are using 6 thyristor. This is a different gate voltages for the 6 thyristors, and this is your voltage, one line voltage, VAB, VC, VBC, VCA, all are one line voltage. And the one more thing, here for PWM technique, we don't want this external circuit controlling. In order to control the voltage, this chopper and this control rectifier is not required. Only we will use only the filter. Okay, directly we will use only the filter. We will not going to use this chopper circuit and control rectifier in order to control the voltage. Directly the supply will be given to the filter. Suppose if there is any noise or harmonics, that can be filtered out, and then it will be given to the 6-step inverter, and the other things we are not going to use. And here what are the major advantages of your voltage source inverter? Okay, the advantages of voltage source inverter is harmonics are reduced, and that too where means in PWM technique the harmonics are reduced. Okay, in PWM technique the harmonics are reduced, and here the losses are also reduced. In using PWM technique the losses is also reduced, and you will get smooth motion over low speed. Okay, smooth motion can be obtained using over low speed. So this is about your PWM technique as well as your stepped technique for controlling the induction motor using VSI technique. Okay, thank you students.